This week we start talking about tropical weather. We're moving out of the mid-latitudes and down into the tropics. So what does that mean exactly? So what conditions, for example, are required for development of tropical cyclones? Did you know that hurricanes are called by a lot of different names around the globe? So that's part of why they use the word tropical cyclones there. They're basically weather that's between 23.5 degrees north and 23.5 degrees south. Pretty much no fronts make it into this area. So basically you have uniformly high temperatures, lots of moisture around, especially over the oceans, and very little diurnal temperature variation from month to month. That's conditions. If you lived in Puerto Rico, for example, they've never had a low temperature below 60 degrees. And they very rarely have high temperatures of even to 100 degrees. They're mostly in the 80s and 90s. And that's every day of the year. So if you don't want a lot of temperature variation, move south. Go into the tropics. You're not going to find the temperature varying much. So one of the keys to analyzing tropical systems is the weather in the tropics, there's not a lot of isobars unless there's a major storm. So we use a technique called streamline analysis. What is that? Well, streamline analysis is basically taking the wind and drawing an arrow along it. And you can see here, they can converge. The winds kind of bring into some area right here. Here's a little bit of a circle around this one, for example. All you're doing is following the wind with a streamline analysis. And that will show you areas of convergence, areas of divergence, deflection, various features in the weather. So streamline analysis is really useful down in the tropics. Not quite so much up in the northern latitudes where we live. So with that, let's go on to hurricane characteristics here. Hurricanes typically have an eye. They may not get it until later on in the process, but they typically have some type of an eye. The eye is where the air is descending. There's a tremendous amount of wind blowing upwards in a hurricane. And that wind then gets picked up above it. There's a high pressure. Here we go with this. These are warm core systems. If you look at the temperature profile through a hurricane, you're not going to find any cold air. If you look at the temperatures over here versus the temperatures over here, almost no difference. So what you wind up with is very uniform, very moist conditions. So as the air spirals up, some of it gets pulled away by a high pressure that builds above. Remember, the warm air is less dense. Pressure doesn't drop as fast with height, so you wind up with high pressure up here. On the other hand, you get spirals around it, and spiraling bands of winds. So if you were to look at ISIS today, this is a air mass curve, but it kind of shows, notice the low level, the thunderstorms right in here, which are very close to the center of this storm right now. There's no eye visible right now, at least not clearly on satellite. They claim there's a small weak one with it at this time. But notice the air, the high clouds moving around it, literally in a clockwise direction. You have high pressure already over this system. You have a lot of bands around it too. Notice these little bands. Here's a band, here's a band. If you were to look at a radar right now, you would see different shower locations around it in bands like we were just looking at. So ISIS is a very typical, while not very intense, tropical system right now with the bands and all around it. So moving on down through here, they require very high sea surface temperatures. And one of the areas that really gets it, Gulf Stream, is one area, and Isaias is moving across that right now. And you get warm currents in the Gulf of Mexico, some really 90-degree temperatures out here in the Gulf, and temperatures that are warm for a long way down in the Gulf, providing a tremendous source of energy for these systems. And daily we can get that. Now remember, another thing you need is Coriolis effect. So they don't very typically form within 5 degrees of the equator. However, there have been exceptions, but none have gone across the equator. They do need some kind of Coriolis winds to make them shift into the circular motion you see. And weak winds aloft. Wind shear is something they hate. So with that, here is a 300 millibar weather map right now. Notice the winds down here are 20 knots or so, 15, 20 knots. There's southwest wind shear that's occurring over ISIS right now. So with that, that's keeping it from really getting going. That's a problem for it. It doesn't want these winds up here to be blowing out of the southwest. It would much prefer a little bit of a light easterly wind or whatever with it. Let it high do its thing, but these winds are encroaching on that high, keeping it from really ventilating the system, allowing all that air to get out of there. So that's all a problem for this storm right now. If these winds were to slow down, but they sure don't look like they're going to, we might get more intensification. And sometimes this is a real hard forecast, picking out whether the wind's going to shear or not up there. It's something that we don't do a good job of, and basically that causes a lot of issues in the intensity of these storms. So with that, most hurricanes, major ones, form towards the latter part of August, September, into early October. That's the time frame. And you can see here there's primary breeding grounds. Notice we've had a lot of our storms have been in the Gulf of Mexico so far. Just now that we're getting into July, we're actually starting to see some form a little bit to the east with time here. And as you go more and more of these storms are going to come eastward out of it. There's a tropical depression now right off of Africa. Looks like it's going to go in the middle of the Atlantic and not bother us, but there is one out there. You can see the ocean has to heat up down here for these storms to really get going. And as they get into the winter, they move back away. Saharan air layer. Basically, we've had several of them already this year. We will have more. All they are is a big elevated mass of dry, dusty, very stable air that moves across. Think about it. The dust keeps heating from happening. The stability of that air, it's actually very warm air aloft, so you can't mix through it. It keeps the cooler ocean air down towards the ocean. Yeah, cooler, maybe 80 degrees versus maybe 90 degrees up there at top above it, but still, it keeps it very stable. It just doesn't allow hurricanes to get going and can kill them. So basically, there are 3 parts. Tropical depression is initially when it forms. You're really looking for a circulation. You're looking for a closed low. 23 mile an hour winds are higher. Tropical storm is 39. And then 74 miles an hour winds are higher. And as they move over land, they may change into what we call a post-tropical cyclone, which is literally similar to extratropical cyclone. Similar. They haven't got there yet, but there becomes temperature contrast across them, and things begin to change where they have had all this uniform wind and low wind shear, and all of a sudden they get wind shear. All of a sudden, temperatures begin cooling aloft. They change structure. There are various hazards to hurricanes. Very heavy rain, obviously lots of moisture coming up out of the tropics where it formed. Storm surges, devastating. Strong winds, tornadoes. If you have a very strong storm, think about it. The wind's friction when it hits land is going to slow the low levels of wind. So you're developing even more wind shear in the low levels. And remember, wind shear with thunderstorms is what we need for tornadoes. So with a hurricane, you actually have the conditions there. You may not have the tremendous instability, but you do have very strong wind shear. So it can create these tornadoes. Some storms more so than others. Inland rain can be extremely heavy. Irene, I lived through it. It had a tremendous amount of rain with that storm. And you can see it. over the eastern part here. Winds, obviously, debris with them, they get stronger. Storm surge. Think of it this way. If you have an east wind for the eastern United States or southeast wind, it's coming in off the water, right? That's going to push water inland. So instead of the normal mean sea level that we have, the mean sea level might actually be up 10, 15, 18, 20 feet. All of a sudden, that's the new mean sea level. What happens? That house that was nicely above sea level normally, all of a sudden is below it. Now, think about it. We're talking about a sea level. Sea level varies with tides. So if this occurred at high tide, it would be worse than if it occurred at low tide. So you've got to take tides into consideration on the timing of when these storm surges occur. So just something to think about. And you're going to talk about this with Sandy, because storm surge was huge in New York City area with Sandy. So basically that. There are models that predict that. There have been trends, obviously, the decadal oscillation in temperature, which we seem to have warmer temperatures over the ocean right now than we have, seems to run at about a 20-year cycle. So all these things are playing into tropical weather. So hope you got a little bit of an idea about it, and we'll talk more actually about this hurricane when we're forecasting here in the next segment.